Students, we are given this question. We are expected to calculate the area. Let me foremost draw the figure for this particular question. Can you spot what is the name of this figure? This is a trapezium, and we are expected to find the area of the trapezium. Now if I were to name it as A, B, C, D, then this is what is required. Now we've been given a few information. So we've been given this to be as 20 units, and there is a drop from here, a perpendicular to this base. This is 90, this is also 90, right? And this height is given to be as 8. This side is given to be as 10, and this side is also given to be as 10. And we are actually expected to find this entire base. So we don't know what is that base, right? If we know the base, then we can easily calculate the area. So the question is, how are we going to evaluate that? I hope you are able to understand this question. So this is the figure that is being given. We do not know what is AB, but still we are expected to calculate the area of the trapezium. Now it is imperative to know the formula. So area of the trapezium is nothing but base 1 added with base 2 divided by 2 multiplied with height. So this is the area formula. Now I got base 1, but I don't have base 2. I got a height, and since I do not have one of the bases, we are expected to find that base. So how are we going to do that? Now the first and foremost thing that we would have to do in this case is drop a perpendicular from C down to AB. So this is 90 degrees, right? Now clearly you can see that this distance and this distance are one and the same, because this is a perpendicular dropped and this is also a perpendicular dropped, right, from CD. So clearly I can write this as A. Now let me take this point to be as E and this point to be as some F. So we will consider triangle CEB. So using Pythagoras, so if we were to use Pythagoras, what would this be? This is going to be CE squared plus EB squared is equal to CB squared. Now CB squared is 10 squared, EB squared I don't know, CE squared is 8 squared. So x squared is equal to 100 negative 8 squared is 64. So this is going to give me 36. Therefore x is equal to, we have to take only the positive value, 6. So 6 units. So this is going to be 6 units, right? So we got that. Now next, what I wish to do is I would like to drop a perpendicular from D to this point. Let me have it as some G. Now clearly we can see, we observe that. So what do we observe? DC is parallel to GE, and DC, this, you see this distance and this distance are one and the same, and so we can easily conclude DC is equal to GE. So this would mean, since DC is equal to 20 units, therefore GE is also equal to 20 units. So we have got that, right? Now the question is, what is AG? Now clearly this is going to be 8, this is 10, this is 8, this is 10, this is 8, this became 6, so this will be 6 units. So this entire distance has got to be 20. So therefore the base, it's a bigger base, AB is equal to, what is it? 6 positive 20 positive 6, which is equal to 32, right? This is what we have got. So therefore the area of the trapezium is equal to, the trapezium we're talking is ABCD. This is equal to the first base, which is 32, the second base, which is 20, divided by 2, and the height is 8 units. 2 divides here 4, right? So this is equal to 52 multiplied with 4. 4 times 2 is 8, 4 times 5 is 20, 208. Its area, so we need to give square units. So this is the area, right? So that concludes the solution for this beautiful question. Students, we will move on to the next one.